Here is the original problem. The next thing I did was I wrote an auxiliary equation and set it equal to 0 so I could find my y sub c. I factored it, I solved, and I found my y sub c. I had two real solutions, -2 and -1. Now you look at the non-homogeneous part of this equation and you ask yourself, what annihilates 4x squared? 4x squared, well, that's of our three cases, that's part one, case one, and it's going to be d to an exponent, and the exponent will be one more than your highest exponent on your variable x. So it's going to be d3. Now take d3, set it equal to 0, and find your auxiliary equation, which would be m cubed equals 0. If you solve that, you get m equals 0 3 times. You're going to have repeated factors. My y sub p will be c sub 3 e to 0x plus c4x. That's a repeated factor part. And then c5x squared e to 0x. And then I simplify my equation. And then on this last line, what I've done is I just wrote my x squared first. My x squared followed by my x term followed by my constant. Now, if you look back at your original equation, you've got y double prime. So take your y sub p, which I copied up here. Find your y sub p prime. So take the derivative of each term, and that gives you 2c5x plus c4. Of course, c3, take the derivative, goes to 0. And now find your second derivative. All right. So I'm going to another screen. And I've copied here what the y sub c was and the format of your y sub p. This is the original equation. Okay, on the previous page, we'd found our y sub p, our y sub p prime, and y sub p double prime. You're going to plug each one of these. You need to copy them down from the previous page. You're going to substitute those into your original equation. So yp double prime was 2c5 plus 3 times y sub p prime, that was y sub p prime, plus 2 times my y sub p. And that's equal to 4x squared. On this line, I just distributed the 2 and the 3. On this line, I just wrote it in order, descending order of your variables. You had a 2c5x squared. I wrote that here. And then I wrote my x's. There's this one. And then I had another x, that one. And then what did I have? I had just my 3 constants. 1, 2, 3. So that's what we have here. And now I copied down the 2c5x squared. I factored this x out. Here it is. And then here are my constants. And corresponding parts equal. 4 is the constant on your x squared. That means 4 has got to equal 2c5. So 2c5 equals 4. c sub 5 equals 2. This one has got to equal 0 because over here you could write it as plus 0x plus 0. There's nothing on the right-hand side that has an x. So that means 6c5 plus 2c4 is going to equal 0. And also my constants have got to equal 0. So here we had c5 equals 2. And then I plugged that in here. 6 times 2 is 12. And I solved this equation for c sub 4. And I got -6. And then 2c5, well, c5 is 2. 2 times 2 is 4. c4 was -6. -6 times 3 is -18. So I solved this equation for c3 and got 7. This is my y sub p, the format of my y sub p. So my y sub p is c5, which is 2, x squared minus 6x plus 7. All I've done is substituted in these coefficients. So now I'm ready to write my solution, because on the previous screen I found my y sub c. This is y sub c plus y sub p. There's your solution.